I have a function g of x equals to 4x to the third minus x squared at a point -1 comma -5. The point is when x is equals to -1, you have a -4 minus 1 equals to -5. So in other words, that point is a point on the curve. So what I am trying to do is, first of all, I would like to use the limit definition of derivative to find g prime of x, and then I want to determine the slope of the function at that point, and then I would like to use that point to build a tangent line. Okay, let's start. G prime of x, that is equals to limit as h approaches to 0, and then draw a fraction bar. We have gx plus h minus g of x divided by h, that is equals to limit as h approaches to 0. Let's draw a long fraction bar. G of x plus h, so this is like a composition function, so you have 4 times x plus h to the third power minus x plus h squared. So this is g of x plus h, and then you minus g of x, so you put the whole function in a parenthesis, so 4x to the third minus x squared. Don't forget the parenthesis because you are subtracting the entire function. The minus x squared becomes a x squared, becomes a plus x squared after distribution, divided by h. And then before we move on, so let me specify that this is g of x plus h, and then this piece is g of x. All right, so in this problem we have a x plus h to the third power. The way I expand a third power is using a Pascal triangle. So Pascal triangle, the top Pascal triangle is like a pyramid. The top of the triangle is always 1, and then the second line is always 1 and 1. For each line we start at 1. For the next number, I am going to take these two 1 plus 1, that is equals to 2, and then we end a line with 1. The next line we start at 1. 1 plus 2 is equals to 3. 2 plus 1 is equals to 3, and then we end with a 1. The next line start at 1. 1 plus 3. 3 plus 3. 3 plus 1, and then we end with a 1. The next line we have a start with a 1, and then 1 plus 4. 4 plus 6. 6 plus 4. 4 plus 1, and then we end with a 1. And then this can go indefinitely. Okay, we can just keep moving, but we don't need that many lines. So how do we use this? Before we do that, so let me move the triangle over here so I can save more space to do the algebra. I will just move this one more time. So move that over here. Okay, so we do not count the first line. So the first line doesn't count. And then the second line, the 1, 1, we count that as the first line. And then this is the second. And then this is the third. And then this is the fourth. So on and so forth. We are trying to expand x plus h to the third power. So since that is raised to the third power, we will be using this line. How do we use the 1, 3, 3, 1? So the 1, 3, 3, 1, they are coefficients. So here is how we do it for x plus h to the third power. You write 1, 3, 3, 1 on your paper. And then the first variable, x, so that is x to the third power. I wrote h, so x to the third power, and then x squared, x to the first, and then x to the 0 power, which is equals to 1. So you don't write x to the 0. And then h to the third, h squared, h to the first, and then h of 0. So since this is a plus, then this will be all plus. So that's the expansion of x plus h raised to the third power. So what if, just a what if, you are trying to expand x minus h to the third power? You don't see that in the limit definition, but let me show you that anyway. So for x minus h, so we write this down again. So we have x to the third, and then 3x squared h, and then 3x h squared, and then h to the third, right? For minus, you will go by this plus, minus, plus, minus. They alternate. For plus, it's all plus, easy. For minus, you go by plus, minus, plus, and minus, and these alternates. All right, let's do the expansion. So to give myself more space, I am going to box this whole thing and then move that a little bit more to the right so I have more space to show my work. Okay, next step. Having a lot of space is very important because we are going to get a very long numerator. So x goes to 0, and then we draw a very long fraction bar. So we have 4, and then we put that over x to the third plus 3x squared h, and then plus 3xh squared, and then plus x to the third. I always double check my work because there are so many variables and exponents. It is easy to make mistakes. So x to the third, 3x squared h, 3xh squared, and then x to the third. And then minus x plus h squared. So we expand that inside this parenthesis. So that will be x squared plus 2xh, and then plus h squared. And then we subtract 4x to the third, and then minus minus, that becomes plus x squared. And then divided by h. And then multiply the 4. Long fraction bar. You have 4x to the third plus 12x squared h plus 12xh squared, and then plus 4x to the third. Double check. 4x to the third plus 12x squared h plus 12xh squared plus 4x to the third, and then minus x squared minus 2xh minus h squared minus 4x to the third, and then plus x squared. And then we have the whole thing divided by h. So let's do some simplification. I can see that there is a 4x to the third, and then there is a 4x to the third. Also, there is a minus x squared, and then there is a plus x squared. So they got completely cancelled. Anything else? I think that's it. So the rest of the terms, bring it down. You have limit as h approaches to 0, fraction bar, 12x squared h plus 12x xh squared plus 4x to the third minus 2xh minus h squared divided by h. Now it's a good time to do a checkpoint. Make sure every single term in the numerator has an h attached to it, because we need to factor one h out. And then we get rid of the h in the denominator. So we factor one h out. Limit as h goes to 0, take one h out. And then we have 12x squared plus 12xh plus 4h squared minus 2x minus h divided by h. And then we get rid of this h, right? So we get rid of this h. So now it's safe to plug in h because we are no longer having a 0 in the denominator. So once you plug in an h, this becomes a 0, this is a 0, this is a 0. So we only have 12x squared minus 2x left, and this is the answer. What is this stands for? This is g prime of x. So this g prime of x, listen, describes the slope of function g at any x value. So this g prime of x is the slope of function g at any x value. There is a variable, that means the slope is changing. So let's say you want to find the slope of function g when x is equals to 0. Good. Then all you have to do is you plug in 0 to g prime of x. And then the g prime of x tells you what the slope is. So when you plug in an x value to g prime, you get a slope. When you plug in an x value to g, you get a point, you get an order pair, you get a location. How's that? Plug in an x value to function g, you get a location of a point. Plug in an x value to g prime, you get a slope. And then what about the tangent line? So we are trying to build a tangent line. So let's switch to another color. So now we are doing tangent line. What color should I choose? Let's pick this. So now we are building tangent line. What's the point? -1, -5, right? So the point is -1, -5. So that means x is equals to -1. So the slope is equals to g prime of -1, 12 times -1 square, right? And then minus 2 times -1. So that is equals to 12 plus 2. That is equals to 14. 12 plus 2. that is equals to 14. So we have a slope, and then we need to build a line. So we have a slope, we have a point. We have to use a point slope in, we have to, that is y minus y1 equals to slope times x minus x1. This is called point slope form. Point slope form. So y minus negative 5 equals to slope, and then x times x minus x1. So we have y plus 5 that is equals to 14, and then x plus 1, right? So you have y equals to 14x plus 14, and then minus 5. Let me double check. 14x plus 1, so 14 minus 5, that is equals to 9. So y is equals to 14x minus plus 9. What is this called? This is called equation of the tangent line. So this is called equation of the tangent line to function g at a specific point, which is -1, -5. So what if you let x equals to, you want to pick another point where x equals to 10. Alright, then that gives you a different tangent line. Alright, so that is the end of this video. If you think the instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're on your way out. I appreciate your help and support. I will see you all in the next problem. Signing off for now.